A 1.6-mile steel giant carrying 30,000 vehicles daily crumbles in seconds. In the dead of night, a massive cargo ship slams into Baltimore's Francis Scott Key Bridge, sending 6 workers into the icy Patapsco River. How did a $2 billion lifeline collapse so fast? What went wrong with the ship? Stay tuned as we uncover the shocking failures and hidden risks behind this disaster. On March 26, 2024, Baltimore's Francis Scott Key Bridge stood as a vital artery, carrying over 30,000 vehicles daily across the Patapsco River. Opened in 1977, the 1.6-mile steel truss bridge was a marvel of its time, designed to withstand the demands of heavy traffic and harsh weather. Its 4-lane deck supported commuters, truckers, and the Port of Baltimore's bustling trade, one of the busiest ports on the U.S. East Coast. Named after the author of The Star-Spangled Banner, the bridge was a symbol of American engineering prowess. But that night, everything changed. At 1:27 a.m., the Dali, a 984-foot Singapore-flagged container ship, left the port loaded with cargo bound for Sri Lanka. Weighing 95,000 tons when fully loaded, the ship was a floating behemoth, capable of carrying thousands of containers. As it navigated the narrow channel of the Patapsco River, the crew reported no issues. The bridge, illuminated against the night sky, loomed ahead, its steel framework steady as it had been for decades. Yet, unbeknownst to the crew or the workers on the bridge, a cascade of failures was about to unfold. Just minutes before the collision, the Dali suffered a total power blackout, losing propulsion and steering control. The crew scrambled to restore power, but the ship was now a drifting giant, hurtling toward the bridge at 8 knots, about 9 miles per hour. On the bridge, 6 construction workers were filling potholes during an overnight shift, unaware of the approaching danger. The stage was set for a disaster that would expose critical flaws in both maritime safety and bridge design, flaws that had gone unnoticed for years. As the Dali drifted closer to the Francis Scott Key Bridge, panic set in on the ship's bridge. At 1:24 a.m., the crew sent a desperate mayday call, warning authorities of the power loss and their uncontrolled trajectory. Harbor pilots on board tried to drop the anchor and steer the ship away, but the massive vessel's momentum was unstoppable. The Port of Baltimore's control center received the alert and acted fast, ordering police to stop traffic on the bridge. Within minutes, officers blocked both ends, preventing more vehicles from crossing. But for the 6 construction workers on the bridge, there was no time to escape. They were part of a maintenance crew, immigrants from Mexico and Central America, working a routine overnight shift. Equipped with basic tools and unaware of the looming threat, they had no warning system to alert them. At 1:29 a.m., the Dali's bow struck one of the bridge's main support piers, Pier 17, with devastating force. The steel truss, designed in an era before such massive ships were common, couldn't withstand the impact. Within seconds, the central span buckled, and a 1,200-foot section of the bridge collapsed into the 47-degree Patapsco River. The workers, along with their equipment, plunged into the dark, frigid water. Debris from the twisted steel rained down, and the Dali, now entangled in the wreckage, came to a halt. Emergency responders raced to the scene, but the scale of the destruction was overwhelming. Coast Guard boats and helicopters scoured the river for survivors, while onlookers watched in horror as the iconic bridge lay in ruins. The collapse not only claimed lives, but also severed a critical link in Baltimore's infrastructure, raising urgent questions about why such a vital structure was so vulnerable. In the chaotic hours after the collapse, Baltimore's emergency services sprang into action. By 1:45 a.m., Coast Guard teams were combing the Patapsco River, their searchlights cutting through the darkness for signs of the 6 missing workers. Divers navigated treacherous waters filled with jagged steel and concrete debris, but the cold and currents made rescue efforts grueling. By dawn, hope faded. Authorities confirmed the workers were presumed dead, their bodies unrecovered due to the hazardous conditions. The tragedy gripped the city, with tributes pouring in for the workers, described as hardworking fathers and husbands. Meanwhile, investigators from the National Transportation Safety Board, ONTSB, arrived to piece together the disaster's cause. Their focus turned to the Dali's catastrophic power failure. Early findings revealed the ship had suffered 2 blackouts, the first moments before the Mayday call, and a second just before impact. The crew had briefly regained power, but it wasn't enough to steer clear of the bridge. Experts pointed to the ship's electrical system, suspecting a failure in its generators or fuel supply. The Dali, built in 2015, was modern, but questions arose about its maintenance and inspections. The bridge itself also came under scrutiny. Designed in the 1970s, it lacked modern protective barriers, like fender systems, which could have absorbed the ship's impact. Such systems were standard on newer bridges, but absent here due to cost-cutting during construction. The collapse exposed a harsh reality. The Key Bridge was built for a world of smaller ships, not the massive vessels of today. As investigators dug deeper, the port of Baltimore faced a crisis. The blocked channel halted all ship traffic, stranding millions of dollars in cargo and disrupting supply chains. The disaster was no longer just a local tragedy. It was a national wake-up call about aging infrastructure and maritime risks. As the investigation deepened, the Francis Scott Key Bridge's vulnerabilities became painfully clear. Built in 1977, the bridge used a continuous truss design, where the loss of a single pier could trigger a catastrophic collapse. Pier 17, struck by the Dali, was one of only 2 main supports holding up the central span. Unlike modern bridges, it had no redundant supports to absorb such a blow. Engineers noted that the bridge's piers were protected only by small concrete dolphins, barriers too weak to stop a 95,000-ton ship. In the 1970s, cargo ships were far smaller, rarely exceeding 50,000 tons, so the bridge wasn't designed for today's megaships. Retrofitting it with stronger fenders or additional piers was discussed in the 1980s, but dismissed due to high costs. Meanwhile, the NTSB's probe into the Dali uncovered troubling details. The ship's power outages stemmed from a faulty electrical system, likely a generator failure. Data showed the crew switched to a backup generator, but it too failed under the load. Maintenance records revealed prior issues with the ship's fuel quality, which may have clogged critical systems. Singapore's Maritime Authority, responsible for the Dali's oversight, faced scrutiny for lax inspections. The collision wasn't just a freak accident, it exposed systemic gaps. The bridge's outdated design and the ship's mechanical flaws formed a perfect storm. By April 2024, the economic toll was staggering. The port of Baltimore, handling 50 million tons of cargo annually, remained partially closed, costing the U.S. economy an estimated $100 million daily. Workers, from dockhands to truckers, faced layoffs, while businesses scrambled to reroute shipments. Engineers and policymakers began questioning how many other U.S. bridges faced similar risks. With over 600,000 bridges nationwide, many built decades ago, the collapse sparked a race to reassess infrastructure safety. The weeks following the collapse saw Baltimore mobilize for a massive cleanup effort. By late March 2024, the Patapsco River was a graveyard of twisted steel and concrete, with the Dali still pinned beneath the wreckage. The U.S. Army Corps of Engineers led the operation, deploying cranes capable of lifting 1,000 tons to clear debris. Divers worked in near-zero visibility, cutting through submerged beams to free the ship and recover the workers' remains. By April 25th, 4 of the 6 workers' bodies were found, bringing some closure to grieving families. Clearing the channel was critical. The port's closure disrupted 8,000 jobs and delayed shipments of cars, coal, and steel. By May 20th, the Dali was refloated and moved to a nearby terminal, a major milestone. The cleanup cost over $100 million, with federal funds covering most expenses. As debris was hauled away, plans for rebuilding emerged. Maryland officials estimated a new bridge would cost $1.7 to $1.9 billion and take until 2028 to complete. Engineers proposed a cable-stayed design, stronger and taller to accommodate modern ships. The new bridge would include robust fender systems and redundant supports, learning from the Key Bridge's flaws. But funding was a hurdle. Congress debated how to split costs between federal and state budgets. The tragedy also prompted a broader reckoning. The NTSB's preliminary report, released in May 2024, confirmed the Dali's power loss was due to a fuel pump failure, triggering the blackouts. This finding led to calls for stricter maritime regulations, including mandatory tugboat escorts for large ships in narrow channels. Across the U.S., states began inspecting bridges near busy ports, identifying dozens with similar vulnerabilities. Baltimore's loss was a stark reminder of the price of neglecting infrastructure. Yet, as the city planned its new bridge, questions lingered about preventing the next disaster. The collapse of the Francis Scott Key Bridge left lasting scars on Baltimore and beyond. By mid-2024, the economic fallout was undeniable. Businesses tied to the port lost billions, and supply chain disruptions rippled across the U.S. East Coast. The human toll was even heavier. Families of the 6 workers filed lawsuits against the Dali's owner, Grace Ocean Private Limited, and its operator, Synergy Marine, alleging negligence in maintaining the ship. The companies countersued, blaming outdated bridge design and seeking to cap liability at $43 million. The legal battles, expected to drag into 2026, underscored the complexity of assigning blame. Meanwhile, the disaster reshaped infrastructure policy. The Federal Highway Administration launched a $320 million program to retrofit vulnerable bridges, prioritizing those near major ports. States like New York and California fast-tracked inspections, finding over 100 bridges with inadequate pier protections. Maritime regulations also tightened. By late 2024, the Coast Guard proposed mandatory power redundancy systems for large cargo ships. Baltimore's rebuilding plans gained momentum, with construction bids opened in September 2024. The new bridge, dubbed a 21st century marvel, promised cutting-edge safety features, but taxpayers worried about costs. Engineers emphasized that modern designs could prevent a repeat tragedy, yet skeptics questioned whether budget constraints would again compromise safety. The collapse also sparked a global conversation. Ports in Europe and Asia began reviewing their own bridge protections, fearing similar risks from megaships. The Key Bridge disaster became a case study in engineering schools, teaching future designers about redundancy and resilience. For Baltimore, the road to recovery was long, but the city's resolve grew. The tragedy exposed how progress, bigger ships, busier ports, outpaced infrastructure. As the nation grappled with these lessons, one question loomed large. Would the next bridge be ready for the challenges of tomorrow? The Francis Scott Key Bridge collapse became a global wake-up call for infrastructure safety. By early 2025, nations from Singapore to Rotterdam were upgrading port bridges, adding stronger fenders and redundant supports to handle megaships. The disaster's legacy reshaped engineering standards, with new guidelines requiring bridges to withstand impacts from vessels up to 100,000 tons. In the US, the tragedy fueled a $1 trillion infrastructure bill, earmarking funds for 5,000 aging bridges. Baltimore's new bridge, now in design, symbolized this shift, with plans for sensors to detect structural stress in real time, yet the human cost lingered. Memorials for the 6 workers dotted the city, and their families pushed for stricter workplace safety laws. The NTSB's final report, due in mid-2025, promised more answers about the Dali's failures, but early findings already drove changes, like requiring tugboat escorts in all US ports. The collapse showed how interconnected our world is. One ship's failure could cripple a city's economy and expose decades of neglected upgrades. As Baltimore looked to 2028 for its new bridge, the world watched, knowing another disaster could strike anywhere. Baltimore's new bridge promises to be a fortress against megaships, but another port city is hiding a secret. A bridge, older than the Key, sits unprotected, with ships twice the Dali's size passing daily. Which city is next?